this way the recording will be in 2 different components, so the recording will be slightly shorter. All right, on to what we're gonna do. Remember I assigned this week, I assigned for day 1, which was yesterday. The assignment is 1.4 and 1.5. I did not assign work for every single day. You can look up the homework assignment right now. What's being assigned yesterday is 1.4, 1.5. Today, I think it should open. Let me open today. Somehow it's not AM, is PM. I should change the date. Oh, that's what's the problem. So let's make it that way. That's 1.7. That's what what we're gonna talk about today. 1.8. Make it today. That way both of them will be open. So that way right now there are 2 assignments for yesterday, 2 assignments for today, and then the rest of them are for the rest of the rest of the week. So day 1 is simple interest and compound interest. Day 2 I assigned, let me know if the assignment is too much, because the summer class. Um, so day 2 is 1.7 time value of money. And then day 3, I assigned 1.8 and 1.10, the nominal rate of interest. And day 4, I've not posted any insert there. So I guess I will assign the last assignment for the week is 1.12, force of interest. Okay, so today let me try to introduce what we're talking about, and we can use chapter 1 as basically in the first week we are going to go over chapter 1 of the text. Chapter 1 is the growth of money. Okay, so overall there are roughly 15 sections, but the first few sections are laid out like this. 1.1 is introduction, 1.2 is what is interest, 1.3 is talking about accumulation function and amount function, 1.4 is simple interest / linear accumulation function, which are the same thing. 1.5 is compound interest, 1.6 is interest in advance or discount rate, and 1.7 is discount function. And then after that, there's 1.8, 9, 10, 11, 12, but I kind of don't have that. We'll wait we'll talk about it when we get there. So start with, you can read 1.1, which is an introduction about what we're gonna do. Basically the whole chapter 1 is trying to find out appropriate model for how money is growing. So one of the concepts we have to talk about when we talk about the growing of money is, if money is growing, meaning that it's going to slowly grow from a small value to a higher value. So let's assume the smaller value is K and the higher value is S, then the differences between the two is called the interest. Okay, so why do we have interest? There are a lot of reasons, and I guess one of the reasons is money can be considered as resource, and resource can be utilized, and it can produce more result or produce more money in a sense. Okay, here is what I quoted from the textbook about the reason why there's interest. Why is money growing from smaller value to a higher value rather than growing from a smaller value to an even smaller value? All right, so These are two of the theory. One is investment opportunity theory, which explain why there's theory. Because see, if you have $1,000, it's it shouldn't stay as $1,000 in 1 year. So a year later, this $1,000 has been utilized for possible investment. So you can invest this $1,000 into put it in the bank. It grow into say 1,020. So that's the interest is being provided by the bank. Or you can put this $1,000 into the money market, and let's say we put it in a mutual fund, and by the end of the year, it will be it will be a larger value, and so that's the theory. And you can also give your $1,000 to your friends, and your friends is doing business, and then so that's investment opportunity. There's different type of investment opportunity. One way or the other, $1,000 is possible to increase, very possible to increase to higher value. Another reason for interest is time preference theory. So like do you want to have $1,000 now, or do you want to have 1,000 a year later? We certainly prefer to have $1,000 now, which means to have money now is always better than having it later. So if you want to give this $1,000 to somebody later rather than now, you have to see pay them to agree for a less preferred choice. So time for preference theory. Anyway, so we don't have to think too much about why interest exists and why people have to pay interest, and that's already become the norm, and therefore we always assume money is growing rather than money is decaying or disappearing. All right, so here 1.3 talk about accumulation function and amount function. What's the difference between the two? So number one, AKT. Actually, the capital K is supposed to be lowercase. It has to be slightly smaller than the capital A. So K is in fact the principal. So say if you have K dollar, after time t, the little t represent the time. After time t, this k dollar is no longer k dollar. It's become AKT. Supposedly, this AKT is higher than k, and this AKT is what we called amount function. A as in amount. All right, what is accumulation function? Accumulation function is what if you get $1 and after time t, how much this $1 has grown into? That's the AT, lowercase a, AT. Now that is being called the accumulation function is model the accumulation of $1 into something bigger. Now, what's the relation between the accumulation function and the amount function? The amount function is the total amount, assuming the original money is K dollar. Now, accumulated function is amount of the money that you have if assuming the original money was $1. So these two are very similar. Theoretically, many situations, we're assuming that AKT and lowercase at, they're proportional. If $1,000 is growing to 1,020, then $1 should grow to 1.02. See, they were supposed to be proportional. In another way, we're saying AKT should equal to K times lowercase at if they are proportional. For the most part of the book, we're assuming they are proportional. On some of the special cases, we're assuming they're not proportional. All right, so that's the differences between accumulation function and amount function. All right, 1.4, let's talk about simple interests. What is simple interest? Simple interest is assuming that the accumulation function and the amount function, we're assuming they are both linear. They're both linear function. But start with a linear function for the accumulation function. Remember, accumulation function start with 1. So if you have a linear increase, assuming it's 1, meaning that when t equal to 0 is 1. So a is 0, lowercase a is 0 equal to 1. Maybe we want to be able to write on it. I was trying to save some time by talk through the PowerPoint. All right, so This is the accumulation function. Remember, accumulation function A of t is assuming you got $1 and it's been growing to AT. So AT is comparable to $1, bigger than 1, but relatively similar to 1. So another thing we know is that A of 0, initial value of the accumulation function is 1. All right, if it's linear, simple interest meaning it's a linear function, linear accumulation function, then A of t is supposed to be, say, mt plus b. B will be the interest of m will be the slope. Since a of 0 is 1, now this a of 0 equal to b, so that's the initial value, and therefore b has to be 1. Okay, that gives us this at equal to mt plus 1. I'm trying to lead using a linear model in college algebra to lead to this formula there. Okay, so it looks already pretty similar. 1 plus m, bm is a slope. T is a time, but we do not use m. M is a college algebra concept, college algebra notation for the slope. In here, we use a little letter s for the slope of the accumulation function. So then again, amount function in the text is this AKT. K is a principal value, and we are assuming it's proportional to the accumulation function. So K times AT. Remember, lowercase at, this is how much money is growing if you only get $1. Now, if you get $K, then K has to multiply A of t. Now, if A of t is 1 plus st, that's K times 1 plus st. So this kind of explains the simple interest and linear accumulation function, and that's the main part of session 4. All right, so from here, we're gonna intercept some K concept that sounded different, and the notation is specifically for this book. I hope it still makes sense to start with the first definition. This is an interest effective interest rate for a particular time interval. Let's say the time is from T1 to T2. So the interest rate, this is interest rate, not interest. If it's interest, it will be AT2 minus AT1. Remember, interest is how much more money at a future time compared to a present time. Assuming the present time is T1, the future time is T2. So now you take the future value minus the present value, that is the interest. The interest divided by the present time quantity, that is a interest rate from T2 to T1. Now, this same definition works the same for the amount function. So the amount, basically 1.3.1 equation, is when you have $1 initially, is assuming the principal is $1. So AKT is assuming the original amount is K dollar. The interest rate, it would be AKT2 minus AKT1 over AKT1. 1.3.5 and 1.3.6, they're actually the same if the AKT is proportional to AT. Below, we're making it more specific to a certain time interval. So 1.3.7 is referring to the time interval n minus 1 to n. So that is the nth time interval. So we're assuming n represent, for example, years. So from 0 to 1, first year, 1 to 2, second year, 2 to 3, third year, right? 0 to 1, 1 to 2, 2 to 3, 3 to 4, and that's fourth year. And that's why we have n minus 1 as a present time and n as a future time. So anyway, In, which is a formula 1.3.7, is the same as 1.3.5, except we're using a time. The time is being represented with integer n and n minus 1. This formula can be rewritten as an equal to an minus 1 times 1 plus I, which makes sense. I mean, the present value multiplied by the growth factor. the gross factor is 1 plus the interest, right? And then you get your future value. So the future value is an, present value is an minus 1. But this relation between the two is 1 plus I. 1.3.8 is a formula for I1. Now, I1 is A1 minus A0 divided by A0, but A0 equal to 1 if it's accumulation function. So that means A1 minus 1 equal to I1. And that's a special formula we should remember. It might be useful when we try to determine the interest rate per time period. Okay, so here we have an example. Tanya loans Renu 1,600. Renu promised that in return she'll pay Tanya 2,000 at the end of the 4 years. To what rate of simple interest does this correspond to? So this is kind of a information from the question matches our model. It's trying to figure out the um, the try to figure out the appropriate model for the question. Okay, so rate of simple interest. So then basically our amount function, we can calculate the I for um, right, so the initial value obviously is not 1, so that's our A 0t, not 0. Create 1,600. Oh, let's just call that 80. So we have A0 equal to 1,600, and we have a 4 in 4 years. So we have A4. We try to match this with our model, and that gave us 2,000. And then remember previously we have that if it's simple interest, then the simple interest have a amount function that look like k times 1 plus st. If we, assuming that this is our k, because that was the initial value, so we'll have 1,600 plus 1 plus s. I think that's the interest rate. We're trying to calculate the rate of interest. I think that's the s multiplied by the t. All right. And then we can apply the A4. A4 is equal to 1,600 plus 1 plus s times 4, or we can just do 4s. And this is equal to 2,000. All right, solving this equation, we'll be able to find the simple interest rate, which is the s, I guess, is s is equal to 2,000 divided by 1,600, then minus 1. That gives us a 4s, then divided by 4. Okay, so we finish the calculation, we'll be able to find our simple interest rate. That's one example, utilizing the model. All right, second example. Antonio loans his brother Bob 2,400 for 3 years at 5% in simple interest. The brothers agree that if Bob wishes to repay the loan early, he may do so, and the repayment amount will still be based on 5% simple interest. Find the amount Bob would be required to pay if he makes his repayment at the end of the 3 years. What if the repayment is after 2 years or after 1 year? Calculate I1, I2, and I3 if the loan lasts the full 3 years. All right, we kind of have to figure out the amount. This question is different from previous one because we now have the interest rate. We do not have the final payment, and that's something we need to calculate. So following what we were talking about, the loan amount is our K. All right, so maybe it's easier to type. K is equal to 2400. Loans for 3 years, so the S equal to 0.05. We're talking about simple interest. So then we can, with this, we are able to calculate the amount. So after 1 year, we'll get 2400 multiplied by 1.05. Okay. So this, I mean, in order to calculate the interest per period, we kind of have to calculate the amount. So that is 2520. Right, that's how much he has to pay if he paying it 1 year later. Agree if he wish to repay the loan early, he may do so. The repayment amount will still be based on the 5% interest. Okay, so this is a repayment in 1 year. So if he repay in 2 years, and that will be 2400 multiplied by the amount function. The amount function will be 1 plus 0.05. This is 2 years, so time 2. Okay. So what is this calculation is going to give us? 2640. All right, and then the third one of payment at the end of 3 years, whatever. 1 year. Okay, A3 is equal to similar calculation, but it's 3 years. So the answer would be, of course, if you waited too long to pay your loan, you might end up have to pay more. So 2760. Okay, so this is a malfunction, but the question, it kind of answered the first few. Find the amount it would require to pay if he makes a payment at the end of 3 years, 2 years, or 1 years. And then we ask you to calculate I1, I2, and I3. And you can see that they're not exactly what we anticipated. Remember, we have 5% in simple interest rate. Why are they saying that they're equal to 5%? I believe I1 should be 5%, but it's slightly different for the following year. So for example, if we were to calculate I1, so it's going to be A1 minus A0. It's the interest rate in the first year and divided by A0. Okay, now A0 is a 2400. Okay, then this is going to be subtraction of the interest. So you have 2520 minus 2400 is 120. So the result is going to be the 5%. So it's equal to the simple interest rates that we talk about. Now I2 will equal to A1, A2 minus A1 divided by A1. See, there is a small problem is that A is changing. So the A1 is now 2520, but here is going to be 2640 minus 2520. And so the interest per year did not change. It's always going to be 120, but the amount is changed. So the annual interest actually becomes smaller. So we have 120 divided by 2520. Okay, so that's the interest rate. So it's actually slightly smaller than 5% because see the denominator is not 2400. So that is going to be that. Same thing for I3, and you can calculate I3 based on what our definition is. It's going to be even smaller. And that kind of makes sense. If you think about it, when you are modeling the increasing of money, see, It start with 2400. If the money is increasing in a linear fashion, so simple interest is allowing the money grow this way. Okay, but compound interest is keep consistently the same interest rate like this. Okay, so compound interest money does grow faster than simple interest. And that you can see the interest is for simple interest rate actually becomes smaller as time goes on. The per period interest rate is not as high as initially that we set up at 5%. So that's one example for simple interest. Okay, this one is calculating exact simple interest that is actual over actual. That is, Brad borrowed 5,000 from Julio on October 24, 1998 at 8% exact simple interest and agreed to repay the loan on May 7, 1997. What is the amount Brad required May repayment? So if you're using simple interest, it is very important to identify the right t. Remember, AT equal to 1 plus ST, interest rate times time. So interest rate payment is proportional to the time. If you are modeling using a longer time, of course, interest will be higher. So this one, this is a solution to this question. We have to find out how much time has passed October 14, 1998 to May 7, 1999. So here are the calculation. In the October, how much day has left from 14 to 31? There's 17 days, and November have 30 days, December 31, January, February, March, April, and May all together. See, in May 7, there's 7 days. So altogether we have 205. A whole year has 365. So the 205 over 65 is what is being called actual. So it's actual days of the year divided by the actual days of the total number of days in the year. So it's 205 over 365 is how we modeling the time, the t. The rest of them follow the a standard simple interest formula, K times 1 plus S is the interest rate, the simple interest rate, multiplied by the time, and that is a actual repayment. Now, another way to do it is to calculate what people call ordinary simple interest rate. I may have made a mistake. Ordinary interest rate method, here are explaining the calculation, is calculating number of days using 360 year 1 minus year 2 plus 30 months 1 minus months 2 plus day 2 minus day 1. Okay, so we're assuming in a whole year there are 360 days instead of 365. This method is less accurate, but it's easier to follow. We don't have to do that calculation of every number of days of the month. We're assuming all the months has 30 days. See, 30 times the differences of the months, and the day, of course, is minus the day. So as example, so this is what's called ordinary simple interest method. This is a way to calculate the correct time for the same question. We have the years 198, 199. You subtract the year, 1 year. All right, then we're going to subtract the months, but May is a new month. So it's May minus October, or 5 minus 10. It's -5. So the month is negative, but year is positive because really we don't have the whole year if we go from October to May. And the day is 7 minus 14. 7 minus 14 will be -7. So with that, we end up this calculation. 360 time 1, that's 1 year. So 30 times -5, and then 7 minus 14 is -7. Altogether, we have 203. So not too bad. Not as accurate as 205. A little less than 205, but we also have less number in the denominator. So this is assuming we have 30 days every month and 12 months in the year. So 30 times 12, we have 360 days in a year. So easier to model, assuming every month have 30 days. The final answer is slightly different, actually slightly bigger. All right, but not much difference. So it's still a way to calculate the exact time for a simple interest model. Um, Lastly, another way to do it is actually find out actual number of days and divide it by 360. That way we actually pay more interest. And this is actually what the bank uses, right? This is called the banker's rule. Suppose a loan, I mean, to basically we have to pay more interest using this rule. The banker's rule is you also still find out how many days exactly, but you're going to divide it by 360. So 205 divided by 360, the actual payment is slightly bigger than the previous two method. So this is a simple interest. Um, this is a simple interest concept. If we move on, we have to start talking about compound interest. Um, but I think read through this. I'm running out of time for the 1 hour. I also worry about the video is getting a little bit too long. But if you do have question about the compound interest, let me know. In the meantime, respond to the survey. Let me know if you're on track, if you have any question. I'll try to utilize the class meeting time as a way to make short videos that I can post online. Also, um, if you need more like other topic, right now it's the first day. I'm trying to follow the text. And also I might not be able to make video for the whole text, but I'm hoping to start. This is a starting point. And you guys are welcome to suggest any topic that is your interest and that really need more example and more explanation. Right, so this ended the topic on simple interest. But if you need any assistance for compound interest for the time value of money, I'll talk about it on Thursday. Um, I think that should be it for today. If you got any, if you have any questions, feel free to email me, call me, text me, post in the discussion board, or respond to the survey. I'm hoping to provide as much as possible way for you to reach me. Um, that should be it for today. And I'll see you on campus. I'm in my office actually. Every day I'm in my office 10 to 11. So if you feel free to um, stop by so we can talk about any question that you have, your progress for the course. All right. Have a fun summer and be up to date with your coursework. Bye guys.